Hello everyone, I'm Ashna Sawan and today I'll be presenting on the topic SVM versus logistic regression. So without wasting time, let's move forward. So in machine learning, classification is one of the most important tasks and most two popular algorithms for classification are SVM and logistic regression. What is logistic regression? So logistic regression basically it gives the probability estimates and it makes the classification easier. And it is easy and it is interpretable. Where SVM, which is more powerful and it works by maximizing the margins between the classes. And because of this, even if the data is complex, even if the data is of high dimensional, it is easier to classify between the data. To compare these two algorithms is important because these algorithms have wide applications in real time, like for spam detection, medical diagnosis, etc. If you want to understand this concept by considering an example, let's consider an example. Classify whether an email is a spam email or non-spam email. So basically, by using logistic regression, if the probability is greater than zero point 0.5, then it will classify the email as a spam email. Otherwise, it will classify it as a non-spam email. Whereas SVM, what it does, it constructs a critical points called as support vectors and based on it forms a decision boundary. What does this decision boundary do? It maximizes all the separation between the two classes and basically it gives whether the email is a spam email or non-spam email. And because of this, even if the data is more complex, even if the data is of high complexity, it can classify it simply. Now, let's deep delve into the concepts of logistic regression and SVM. So, logistic regression is nothing but a supervised machine learning algorithm which predicts the probability based on or by using a sigmoid function. The sigmoid function is nothing but a activation function. And this function maps the values between 0 and 1. It creates a linear decision boundary, and because of this linear decision boundary, it is easy to classify the classes of the data. So, for example, if you want to check or if you want to predict if a person is diabetic or not, and if you consider the factors like age of the person, the DMI, the glucose level, and based on this input features, it will classify by using the sigmoid function that the person is diabetic or not. So if the probability is greater than zero point 0.5, the person is diabetic, or else it will tell that the person is not non-diabetic. So logistic regression has wide applications, and this example is one of them. As we have understood about the logistic regression, let's move forward with SVM. So SVM is a support vector machine, and it is a classification algorithm. It is a supervised machine learning algorithm which we use for classification purpose. So it classifies the data by constructing an optimal hyperplane. And this optimal hyperplane maximizes the decision boundary and it separates the different classes. The classes are separated with more accuracy with SVM. And this SVM relies on the support vectors. Support vectors are nothing but the critical points which are closer to the decision boundary or data points to the boundary. Then with the help of kernel function, SVM can handle non-linear data by projecting them into high dimension. So if the data is of high dimension, SVM uses kernel functions simply. Now, let's understand the example of SVM. So, if you want to recognize the handwritten digits, this is how the SVM works. In the SVM algorithms works as it takes the pixel intensity values from the handwritten images, then it identifies the support vectors and constructs the best boundary that separates it and it tells us whether the digit belongs to this class or whether the digit belongs to that class. And when the digits are not linearly separable, then kernel function is used to transform the data into high dimensions for better separation. Linearly separable data means the data that can be separated by a single linear line. And the data which is cannot be separated like this is not known as nonlinear data. So SPM can be used for classification for the nonlinear data. It uses kernel function for that. Simply. Now let's understand how this logistic regression actually works. We'll get to know this step by step. So step one, it combines the input features into a linear equations. Then it applies the sigmoid function, which is an activation function, to this linear equation and maps the values between 0 and 1. Then it uses a threshold, which is usually considered zero point 0.5, classify the data items. And based on the data items, we have the data is classified into this type or that type. And this is how the logistic regression works in simple way. Then let's understand how SVM actually works. SVM identifies the support vectors from the data, then it constructs the optimal hyperplane that maximizes the margin that separates the two classes. For nonlinear data, it uses a kernel function or polynomial function to project the data into high dimensions. SVM focuses on creating strong decision boundary, which can classify the data, ensuring high accuracy for the data classification. Moving forward, let's understand, are there any limitations to this algorithm or are they perfectly fine? No, they're not perfectly fine. So the limitations to these algorithms are likewise. So if we consider logistic regression, so logistic regression, it assumes linearity, like if the data is more complex or if the data is not linear, then the prediction is not accurate. Also, it is sensitive to outliers. So if you want to sum up into a sentence, it can be said that logistic regression works poorly with big data sets and complex data sets. And with the concern with SVM, so SVM is computationally expensive. It is more complex for harder data sets, and also it is harder to interpret than the logistic regression. It requires careful parameter tuning. Now, let's understand or move forward with the ending part, that is the conclusion. So it can be concluded that logistic regression and SVM are the two most powerful classification algorithms. Logistic regression is fast, it is easier, it is interpretable, it is more suitable for smaller data sets where the data is not highly dimensional or it is not complex. Where an SVM is more powerful, it is flexible, and it is more accurate, and it is especially for the high dimensional data set and complex data. If we consider logistic regression, it provides the probability, whereas SVM it gives a clear decision boundary, whether the data belongs to this class or that class. So basically, if we get higher accuracy in SVM, and that was all about SVM and logistic regression. Thank you for listening to my presentation. Hope you understand it well. Thank you.